Hey, you know what? If you're actually starting to read about DNS and you're to that part where you're really digging into zone transfers and you're thinking, well, wait a minute, this doesn't sound secure at all. You mean that I can go to any DNS server and request a zone transfer and dump all the records in there and read everything on the network? Is this like a hacker's gold mine or what? And the answer is heck yeah, it is. Now, it's not as big as it used to, but man, it still is a huge problem on the internet. But we figured out a way to solve this. And that method is called DNSSEC, or DNS security. Let me show you how it works. It's totally relaxed and groovy, and it's something you should look into from any of your providers when it comes out to it. Now, like I said, if you're learning about DNS, then you've probably figured out, let me go to my pin mode here, that we've got our TLDs, our top-level domains that host the .coms, all that good stuff. And then we have our other lower-level domains down here that are communicating up, and they host all our A records, our pointer records, so on and so forth, right? Now, what DNSSEC does is that actually it allows, switch modes here again real quick, is that it actually allows that when we're transferring information or records back and forth, that we're only communicating with a trusted resource. It's information that we are plugging in here to ensure that that is a solid connection. And how are we doing that? Well, we're actually using an old security standard. We're using keys, right? I mean, when we want to know how something communicates and how we've got a solid standard, that it's secure, that it's reliable, that the entropy is good, we use keys. DNSSEC makes heavy use of how our keys are actually encrypted and travel with that traffic to ensure that that information actually is good. If we don't do that, what happens is that, let's say that problem that I mentioned earlier, that we don't want somebody to communicate and interject in. So here I am. This is my computer, and I'm wanting to transfer or actually send information up. I'm wanting to find out where mybank.com is, right? Now, what a hacker's choice is to get in here and inject a signal that comes over here from a rogue DNS server. We're just going to call this, let me make that server this color here. Yeah, there we go. Kind of some pirate action happening. So what we're doing is I want to inject a record in here, and I'm going to say, oh, you want mybank.com? You want to connect to this IP address that lives over here, and I'm going to actually try and beat this one out before it ever gets answered. What DNS servers do by point of contention is that they'll cache that information up so they're not pounding on those DNS servers for every single record. We're going to cache up. It makes sense, right? I mean, that's how you actually build this stuff out, is that you don't want to ask for every request. You cache it up so you can save it for the next 1,000 people behind you. If that cache gets poisoned and I got an entry there that's redirecting people to the wrong site, that is a major issue, especially if that's a clone site and I'm actually capturing passwords and all that stuff. It's a great way to break in and steal information. What DNSSEC does, let me click over here to a new slide, is that it makes sure that when I have my TLDs, which we're going to go ahead and grab good information from, and I've got my lower level domains here that are going to host that information, that this key signature that actually travels between them is valid, that it's got the right checksum, that the entropys match, that everything is good on this server. So what happens? So let's try, if we try that again. If in this same scenario, I've got my host over here, and he's going to send a request in, and he's going to say, I want to go to mybank.com. Well, I'm going to still have a rogue come in and try and inject that signal, that rogue signal, into this solution, send it down here, try and poison that cache. Now, the difference here that we're looking at when this actually goes on is that this DNS server here, this lower level server, knows for a fact that this server is sending a request or an information update, and the checksums don't match. So what it's going to do, it's going to drop it. It's actually going to send it to the can to make sure that that request is never answered, and then it's going to actually propagate down and filter that DNS entry to the right server. It guarantees chain of authority. And that's really what we want in our DNS. And that's the whole point of DNSSEC. It works fantastic. It is really cool. So why haven't we done it yet, right? If you look at if you look at really what the DNS adoption rate is, this is from obviously from 31 December. These are the places that are actually using it right now, who are doing partial and full. And obviously, you know, I'm certainly not happy to see these for us from the U.S. Canada, Brazil, you know, Australia, a little ahead of the game. They actually will fully implement this stuff. Our top-level domains have made this change and are encouraging everybody to do that. In the U.S., as far as I can think of, the only provider ISP that I know that's doing it right now is Comcast. Comcast will offer it. So if you're on Comcast and you're being hosted by there, definitely look at using DNSSEC to ensure that you've got some good cryptography, that you're getting authoritative information back and forth. If you're like me and you're not on Comcast, you're on other different providers, send your provider emails constantly. Every month, I've got a notice, a little calendar reminder that says, you know, send AT&T an email and say, get on DNSSEC. And I do it every single month. You know, hey, when is DNSSEC going to be available? When's it going to be available? Because it's good stuff. It secures it. But more than anything else, what it does is that, see, this is a real leveraging technology. It's going to allow us this, when we get this in, this is a nice base level technology that's going to allow us to really do some really cool things with SSL, to really climb up the ladder and add so many more encrypted and certified services that's going to make a hacker's job a whole lot harder to get done. This base level technology is incredible, and it is absolutely game changing for providers to put this in. So why haven't they done it? Is it really that big of a deal? Really, let me click one slide here real quick and show you. I want to wrap this up pretty quick. But the problem happens to be really not necessarily whether is it a pain in the tail to set up and configure it. What it means is that as I'm carrying, as you remember when I was talking about the whole key structure piece here, is that when you have to carry these keys, what's going to happen? What is the effect of carrying another packet? Well, my DNS frames are this big. Once I add a key structure to it, well, they get a little bit bigger, right? And a lot of devices, a lot of older hardware, they're going to see this bigger UDP frame. They're not going to want to fragment it, and they're actually going to start dropping that frame. Well, that's not the drop button. Let's go ahead and kick that out and switch. There we go. They'll drop this frame because they don't want to fragment it out. And that cannot work. That means DNSSEC will not get through. It will not pass through a lot of firewalls, a lot of older firewalls out there. What you need to do is that if you need to support this in your local environment, on your local DNS servers, the one thing you want to ensure that your firewall supports is actually a feature. There's an RFC on it as well. It's called EDNO. EDNO is the base level feature that ensures that your DNSSEC entries are going to get through from where they need to go to and then where they need to come from, back and forth, back and forth. If you don't support this, you're certainly going to have some issues once you start trying to plug this in on your network. Man, I am a huge fan of DNSSEC. It solves so many security issues out there. It can really help so many people. But more importantly, more than anything else, is that this is a base level technology that's going to really cause the growth of so many other things. It's really like the space program. The people at the ICANN who run our top level domains and stuff, when they implemented DNSSEC, they said it was the biggest change, the most massive improvement that they've done to the internet in 30 some odd years. That's how important this is. Take a look at it. Make sure your providers support it. If you're hosting your own DNS servers, make sure that you're looking at how to upgrade and support DNSSEC in the future.